Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about thermodynamic properties of steam and steam table. In that, in engineering problems for any fluid which is used as working fluid, the six basic thermodynamic properties are pressure P, temperature T, volume V, internal energy U, enthalpy H, and entropy S. These are the six important properties we need. These properties must be known at different pressure for analyzing the thermodynamic cycles used for work producing devices. The value of these properties are determined theoretically or experimentally and are tabulated in the form of tables which are known as steam tables. The properties of wet steam are then computed from such tabulated data. Tabulated steam values are also available for superheated steam. It may be noted that steam has only one saturation temperature at each pressure. Now, external work done during evaporation. The amount of heat absorbed due to increase in volume when water is converted into steam is called external work done during evaporation. When water is evaporated to form saturated steam, its volume increases from Vf to Vg. Vf to Vg, it increases at a constant pressure. And thus external work is done by steam due to increase in volume. The energy for doing the work is obtained during the absorption of latent heat. This work is called external work of evaporation and is given by, therefore, external work W equal constant pressure P, then Vg minus Vf. As at low pressure, Vf is very small and hence neglected. Work of evaporation is P into Vg. At low pressure, Vf is nothing. Therefore, at low pressure, then work done P Vg when Vf is neglected at low pressure. In case of wet steam, the dryness fraction is given. In case of wet steam, that is W equal P into X into Vg, where Vx is dryness fraction for wet steam. Next one, internal latent heat. The internal latent heat is used to overcome the resistance of the molecular forces which opposes the change of state of the molecules brought about by the formation of steam, while the external latent heat represents the amount of heat which has to be added to overcome the external pressure in pounds per square inch or Newton per meter square Pascal, like the unit is given. Now, the internal latent heat is equal to HFG minus PVG over Joules constant. Here for J equal to 1 in SI units. 1 and SI unit. Next one, internal energy of steam. The actual energy possessed in the steam comprises of only the sensible heat and latent heat. This actual energy stored in the steam is called internal energy. It is defined as the difference between the enthalpy of steam and the external work of evaporation. In other words, we can write enthalpy. Now, internal energy of steam, H equal PVG over J plus internal energy U, where U is the internal energy of 1 kg of steam and pressure P. Therefore, we can write U equal H minus PVG over J. And if steam is superheated, V superheat per kg is given. Therefore, H super is equal HF plus HFG plus C constant pressure or superheat, and T super minus Ts. Therefore, and U equal H super minus PV super over J, or superheated steam. Next, entropy of water. Consider a system in two different conditions. For example, 1 kg of ice at 0 degrees Celsius, which melts and turns into 1 kg of water at 0 degrees Celsius. We associate with each conditions a quantity called the entropy. The entropy of any substance is a function of the condition of the substance, its physical property of the substance. For an ideal gas, the entropy is a function of its temperature and volume. And for a solid and liquid, it is function of its temperature and internal structure. The entropy is independent of the past history of the substance. The entropy of 1 kg of water at 0 degrees Celsius is the same if we obtained the water from ice, or if we cooled the water from room temperature to 0 degrees Celsius. That is vice versa here. When a small amount of heat delta Q is added to a substance at temperature T without changing its temperature appreciably, the entropy of the substance changes, that is, by delta is equal to dQ by dt. This is a formula for change in entropy when heat is removed. The entropy decreases when heat is added, and entropy increases. When heat is removed, the entropy decreases. When heat is added, the entropy increases. Entropy has units of joules per Kelvin. For further discussion, look at here. Entropy is a measure of the disorder or randomness of the system. The greater of randomness in a system, greater is its entropy. The randomness is greater in liquid state as compared to solid state. So the entropy increases when ice melts into water. Now, entropy ds, change in entropy, is dq over temperature, which is equal Cp of water into dt by T. Further, that integrating both sides, that is integral S1 to S2 integrating ds, the units limits s1 and s2 we get, which is equal t1 t2 t1 t2 cpw a constant and dt by t. Therefore here integral of s1 and s2 is s2 minus s1, which is equal cpw log e t2 by t1. This is the expression for change in entropy. If 0 degree Celsius is taken as datum, the entropy of water per kg at any temperature T above this datum will be SF equal CPW log E T over 273. Next, entropy of evaporation. During evaporation, as the liquid state changes to a vapor state, the randomness between the particles increases, due to which the entropy of the system also increases. The entropy of vaporization is the increase in entropy upon the vaporization of a liquid. As the degree of disorder increases in the transition from liquid having a small volume to a vapor having larger volume, the entropy of vaporization is always positive. At standard pressure, that is P O equal to 1 bar, the entropy of vaporization is denoted as delta S vaporization, and it has unit joules per mole Kelvin. Here some expression will do. Here ds, change in entropy, equal dq by t, which gives s2 minus s1, already explained, q over t, where q is the heat absorbed. Q equal to heat absorbed. Then here, when water is evaporated to steam completely, the heat absorbed is the latent heat, and this heat goes into water without showing any rise of temperature. That is Q equal HFG, and S evaporation, entropy of evaporation, is equal HFG over Ts. If dryness fraction given, we have to use it X. That is, we have to use HFG into X. We have to use if dryness fraction given. Therefore, also S evaporation is X into sub G by Ts. For superheated steam, X is 1. For other stage, X is some point less than 1. Then you have to use it that fraction. Next, entropy of wet steam. The entropy of wet steam is 12.71 joules per Kelvin. It's a constant. Calculating the entropy of water when the entropy of wet steam, the entropy of vaporization, and the saturated temperature is given. But here for this, S evaporation is equal SF plus X HFG over Ts, where S wet this wet steam, entropy of wet steam, S wet equal SF plus XFG over TS, where S wet equal to total entropy of its steam and SF equal to entropy of water, SF equal to entropy of water, and then X into HFG over TS is entropy of evaporation. Is therefore SG you can write as SF plus HFG over Ts. Next, entropy of superheated steam. Superheated steam is created by further heating wet or saturated steam beyond the saturated steam point. This yields steam that has a higher temperature and lower density than saturated steam at the same pressure. Superheated steam is mainly used to propulsion or drive applications such as turbines and is not typically used for heat transfer applications. For superheated steam, we have if the specific heat at constant pressure is CPS, then change of entropy, entropy for superheated steam is Cp superheated log E T super over Ts. Here we have to use T super over Ts and log of that one. With multiplication of CPS, we can get it change of entropy of superheated steam. Now, total entropy S super entropy of superheated steam is equal SF plus HFG over Ts plus CPS log E T super over Ts, which is further equal Sg, that is S super. S superheat is Sg plus CPS log E T super over Ts. These things also we can read by Euler chart, that is steam chart. Then enthalpy, entropy, HS chart, that we'll discuss in later videos. So far we discussed about entropy of superheated steam, entropy of wet steam, entropy of evaporation, as well entropy of water, and internal energy of steam, internal latent heat, external work done during evaporation, like the things we found we have done. Please subscribe our YouTube channel.